Units of measure were pretty wonky around the time of the French Revolution. Like the English are basing an inch on 3 wheat barley corns stacked end to end. Different cities all over had their own meanings behind different unit measures. Like a pint in Paris was 2/3 the size of a pint in the northern suburb Saint-Denis. France alone had somewhere around 250,000 different units of weight and measure. The people wanted some goddamn stable units, and the French Academy of Sciences wanted to give it to them. They decided that the new standard unit of measure would be equal to 1/10,000,000th of the distance from the North Pole to the equator passing through a meridian through France. And they would call it the meter from the French metron. But in order to do that, they would need the most precise measure of the size of Earth to date. So they started a survey with two guys making trigonomic triangles trekking towards each other. One started in Dunkirk, northern France, and one started in Barcelona, Spain. And after completing the survey, they had a new and improved distance from the North Pole to the equator. They divided that into 10 million and made a platinum bar that was the new meter standard. Before too long, it became apparent that the survey measure of the Earth was too short. The platinum meter bars remained the standard until 1960. Then the meter was redefined as 1,750,653 atomic wavelengths of krypton. That part's a little over my head. Then in 1983, with new and improved lasers being around, the meter was changed to be based on the distance light travels in a vacuum. And they made the meter the distance light travels in 299,692,458ths of a second. But now, so distance is measured in time, and that's weird, right? Turns out with the invention of the cesium clock, time can be measured more accurately than distance. So it's more practical to have distance be based on time than time be based on distance.